All right, we're still doing standard deviation, but now we're doing it of a sample. It just means that the data that I'm taking it from is from a sample and it's not a population. So the notation changes a little bit. The x with a bar over it is a sample mean, s squared sample variance, s sample standard deviation, and we take one less than the sample size here. So let's do this problem. We have a sample of 6 batteries. We're testing out a new type of battery design, so they measured the lifetimes in hours of 6 batteries. So my N is 6. So first I need to find the mean. So I'm going to add all these numbers up. They come to 24. Divide by 6 equals 4. So the average battery life of these 6 batteries is 4 hours. So the formula says, hey, we want to know each sample battery distance from the mean. Then we're going to take that, square it. Then I need the sum of that whole column. So this is what this chart is doing. So this battery is 1 below average. This is right on the average, 2 above. So 5 minus 4. This is 1 above average. This is right at the average, and 2 below. Then, because I need to get rid of these negatives, I'm going to square this, so there should be no negatives in this column ever. So 1 squared is 1, 0 squared, 0, 2 squared is 4. And take the sum of that column. So it's going to be 4, 5, 6, 7, 8, 9, 10. So the sample variance is going to be 10 divided by 6 minus 1. And minus 1, there was 6 batteries. But the sample standard deviation is going to be when I square root it, so it goes back to the units to undo that square right there. I'll round to 2 decimal places, so 1.41. So the average battery life is 4 hours with a standard deviation of 1.41 hours, which is the average distance from the mean for each of the 6 sampled batteries. Okay, still some more standard deviation, but now we're going to approximate a standard deviation because we have grouped data. We have a number of people in different classes. So to start this, I need all this information, so I need the mean. To get the mean, I need the frequency times the midpoint and the sum of that column. The midpoint is going to be 53. How did I get that? I added 51 plus 55. I took the average of the two numbers. Oops, sorry, so it's 53. Now I want you to note that it depends on which publisher or which book or what computer software, how they want you to get the midpoint. You can also do 56 plus 51 and divide by 2. It could be 53.5. They're both correct, but if you're doing some sort of computer program for your answers, make sure you know which one they want. So you can either add the lower and upper boundaries and divide by 2, or add the lower boundaries of the following classes and divide by 2. They're both correct. I'm going to go with 53. My classes are going up. My class width is 5. So these are going up by 5 as well. So the midpoint times the frequency is what this column is going to be. Then I'm going to need the sum of that. And that's what my mean will be equal to after I divide it by sum of my frequency. So all these people distributed in the 4 classes, there was 21 people. That's my total sample size. So the sum of this column divided by those 21 people is going to give me my mean. 7 times 58 is 406. 8 times 63, 504. 4 times 68, 272. Add those up, 1,288. So I did round that to 1 decimal place. So the mean is going to be 61.3. Then I need to take the midpoint of each class minus the mean. Then I'm going to square that and then multiply it by the frequency. So I'm going to do this all in one row. So 53 minus 61.3, that squared. Then times the frequency. Times this frequency of 7. So 63 minus 61.3 is 1.7 above average squared times a frequency of 8 times that frequency of 4. Almost done. Then it says take the sum of this big column here, and that is going to be 416.69. all over n minus 1. Our n was 21. Square rooted. So that'll be 20 on the bottom. I'm going to round that to 2 decimal places, 4.56. So the average time was 61.3 seconds with an average distance from the mean or standard deviation of 4.56.